So this is the Turbot autonomous guided vehicle. So these are the inputs, right? Inputs, and these are the outputs, right? In most of the microcontrollers, they don't have a memory unit connected because inbuilt there is a memory in order to store the program, and in order to uh, in order to execute the programs and everything, the required memory is already there, right? So why is that? Is this is not a uh, micro processor, this is microcontroller has more resources than microprocessor, more resources, right? More modules. Then here can you see, in here we have analog to digital converter that is inside this big microcontroller. So the microcontroller that has used is the big microcontroller, right? Most of the time we don't have this memory because it is also part of the microcontroller. It is inside the microcontroller unit, right? But we have these inputs, right? These inputs, right? Then outputs we have, right? And we have to give supply like 5 volts. So in order to give this supply, we should have this power unit, right? So yeah, this is working in like DC regulation, right? So from 9 volts to 5 volts we are giving to this, right? To the big microcontroller. So those are the main things, right? So there should be inputs, then there should be outputs, then there should be like the power part should be there. The memory and memory, it is actually in most cases we don't need, right? It is hardly we find that we need a memory inside the microcontroller, right? And if I take another example, so you know, see, so this is Cardo control within a larger network, right? This is Cardo control. Cardo control means, so yeah, this is talking about this Cardo, right? Right? Cardo, right? So, so in here, this model is actually, this should be added like this, right? So there should be a microcontroller, and here, what are the sensors that you are connecting here? Open door sensor, right? And then here output, here window motor, then another sensor, window stall sensor. um, then here window control buttons, they are also given inputs, right? Right. Then here lock actuator, um, then we'll give lock control input as well, right? Then open doses for those kind of things, right? um, so here this is a sensor, this is an input, this is an input, this is an output input, right? So here can you see that that is how we represent an embedded system in a block diagram, right? Block diagram, right? um, so in this one also it should be represented like that. So here microcontroller at the middle, so the temperature measurements, right? Temperature measurements, so those kind of things are here. Okay, so like that. And here we have the compressor signal out, so those kind of things, and human interaction also, those kind of things, right? And when we have network, right, network connection, so it goes both ways, right? Most of the time it will give yeah, output, and it can give inputs as well, right? So those kind of things should be included, right, when you're drawing the block diagram, right? So when you are asked to draw the block diagram, so yeah, if it is network, so you can network module, you can connect it like this, right? That can be done, right? So if we go into like somewhat a deep level of understanding the embedded systems, right? um, Here um, this is our embedded system, uh, what we call the uh, microcontroller unit, right? Microcontroller unit, right? So here this interface to um, here keypad, and if you have a user interface and a display, so they have both the input and output devices, right? So as an example, the keypad is input, right? User interface display, that is an output, right? And um, user interface uh, signals or the commands that you are giving, that is an input, right? So without writing this one, if you want, we can write it like that, so in order to understand it properly, right? So that is also an input. Here this is input, this is an input, and this is an output that we are given in order to um, give the control signals and everything, right? Control signals and everything. Then if we have, so the other variables, so these are from our sensors, right? These are from our sensors. So let's say temperature, humidity, light, so those kind of things, right? Input variables and everything, so these are from sensors, right? So these variables, so the things that we detect from here, they are actually analog, right? Why they are analog? Because what is meant by analog? Analog means it can have any value, right? It can have any value, right? So so let's say the temperature, right? The maximum temperature is 100, minimum temperature, let's say 0 Celsius. So between 100 to 0 to 100, it can have any value, right? This is for the temperature, right? Temperature. And here let's say the humidity can be from 0% to 100% humidity, right? So they are actually, and this humidity that can also take the values between 0 and 100, right? So um, therefore when you have the temperature and the humidity, um, temperature and the humidity, they are actually analog, right? Not they, almost all the things that we are getting from our sensors are analog, right? So maybe the signal condition and data conversion that can be happen inside the sensor itself. And so inside the sensor itself it can happen, right? Inside the sensor, signal condition means it is going to um, make your signal noise free, and data conversion means converting it to a digital level, right? Digital level, right? So these the humidity and temperature, they are analog values, but before we feed in into this microcontroller unit, because microcontroller unit, this is a digital one, right? Digital one, then you have to feed it after the conversion, mm, after the conversion, um, or else so- or else inside this you have to convert uh, analog to digital conversion, then you have to take it into the system, because this is digital, so this one cannot operate. This one, sorry, not this one, this entire thing, this cannot operate on analog things, right? Everything that is fed into the um, processing part of the microcontroller, it should be digital, right? So that's why we have, so this is a digital processor, digital signal processor, this one, right? Okay, so therefore it should be fed into mm, the controlling part or the processing part um, of this one by that. Then mm, then there will be the output, so output will be given into this, right? Will be given into this. So that output, again, it is output is digital output. So sometimes we may require digital to analog conversion in order to do that work, right? So that means, so let's say we are given like um, voltage. So let's say this is output drive is a motor, so then we are giving the voltage value to that motor, right? So therefore it should be again analog. So therefore sometimes you may need to use digital to analog conversion in between output drive and the microcontroller unit. So then you will have this output variables. Output variables means what is happening after that, right? So the motor turning, and so those kind of things. So here then we have link to other systems, right? So actually what we have it in here is this is the control signal. So these are control signals and everything, because you will give the keypad to use interface display your interface signals. Those are control in part, and here these are the things from the sensors, right? And this is from the control, and here these are for the what we call as um, actuators, and here this is, if we take this as the network system, this is into network system, right? So therefore if we go in into okay, so like this. So then in here you will have your microcontroller, and from this input from sensors, right? Then output to what we call actuators. So then in here there will be like network, and also in here we can include the control part as well, right? Control part as well. So this will cover everything, right? So the sensors, actuators, and the networking part, and also the control part. Okay, without just saying these are just inputs and outputs, right? So we will call it as like the control and the display and those kind of things. So here we are giving some signals to this one. So actually it is an input, but we'll call it as like control. Okay. So by using these things we can represent it. Then mm, so as I have told you, right, in which discipline does it involves, right? So it involves in each and every discipline, right? So digital electronic, and not only digital electronic, it is in analog electronics as well. So IC design, computer architecture, software engineering, data communication, uh, control engineering, electric motor and actuator sensors and measurement. So all these things are required in order to design an embedded system. So that's what this means, right? Um, these are not the actually the areas that we are using, right? Actually these are the areas that we require in order to design an embedded system. Digital electronics, we need analog electronics, sensors and measurements, electric motors and actuators, control and the data communication, in order to address the network parts of engineering, in order to write the codes and everything, computer architecture, how effectively that we are writing our code, and IC design. So why we need IC design? Because we have to make it inside a, we have to keep it inside um, inside the device, and also in order to do that we should we should do we should include it inside a device as small as possible, uh, the microcontroller unit and that part, right? Then we require digital electronics and electronics, sensors, emissions, everything we require when we are making a embedded system, right? So okay, so think that would be enough for today. Okay, so this is what I have to cover for the today's class, right? um, so do you have any questions? Do you have any questions? Okay, so if you don't